So our compound angle stuff that we've been working on, we've got a few different things to take a look at. Let's start out where we're going to have an angular drill, an angular boring. So entry on top and then offset exit on the bottom of the piece. So if we're looking at this from the front view, it's going to look something like that. From the end view, looks something like that. The information I'm going to give you about it is this. This depth here is 0.75 inches. The offset here from center of the hole on top to center of the hole on bottom, 0.40 inches. And here, I'll go 4.5 inches here. What I want to find is if I come up here, oops. Remember what we're looking at is kind of a box here. That describes it, and that goes corner to corner across that box. Within that box, since our hole is going corner to corner, I want to define R, the angle of rotation. Up here, this will be T up here, the angle of tilt, and L, the length of the bore. So, find R, T, and L. I'm going to give you a couple minutes to look at it, then we're going to go through it as a group. Okay, tell me where to start.
For the length, it's the height, the width, height square, yeah. The height, width, and length squared.
Okay. So 0.75 squared plus 0.40 squared plus 0.45 squared, which comes out to be 0.96 inches. Works for me.
0.9617.
Okay, perfect. So if we wanted to go to 3 digits, 0.962 is where it would be. Yep. R, how do we find R? Inverse tangent of what? Okay, so what's the width? 0.45 divided by length of 0.4. Now when you're looking at that, the opposite side is bigger than the adjacent side. What's that tell us about our angle when we're doing a tangent? It's bigger than 45 degrees, yes. Little things like that, keeping them in the back of your mind, keeps you from making bad mistakes. So what's that come out to be for an angle?
48.37.
48.37 works for me. So there's R. How do we find T?
Now the 0.45 is the width?
Yeah, 0.45 here. That's right here is 0.45. And the 0.4 is here.
And the 0.4, what are we calling the 0.4?
That's the length. That's capital L. Little L is the length of the bore. Capital L is the length of the block. How do we find angle T? It's an inverse, but what trig function? Cosine of
0.75 divided by 484.
You got it. 0.75. That height divided by the length of the bore, which you got to be 0.962, which comes out to be Was it 38.76 degrees? So did you guys get 0.962 for the length? R of 48.37 and T of 38.76. Okay. So now I'm just going to draw out the part with the hole in it here. Again, we are going corner to corner in our box. Rotation and tilt. But this time, if I look at it from the front view, what I am given is that the hole forms an angle of 28 degrees with the vertical there, and from the end view, my hole forms an angle of 31 degrees. So I want you to use those two angles to find the angle of rotation in the tilt. I will pause. Tell me where to start. Not everybody at once.
You need to divide the lengths out to those angles.
Okay, how do I do that?
You have to come up with a depth, and we use one of those 10-6 values.
Okay,
And then it would be,
so this one here,
you have to use the tangent of one length.
equals,
Have it set up, I put A over 10. Dot together those 10.
okay, yep. So we cross multiply and divide to get that A is,
5.32.
okay. Then over here,
Tangent of 31, and then B over
cross multiplying and dividing gives us that B is
0,
6.01. Now what? Well, basically now we have the exact same situation we did before, right? It's not going to be part of our answer, but we do need a theoretical length. 5.32 squared plus 6.01 squared plus 10 squared gives us what for that working length? It's not really a length, it's just one we're using to work on our calculations. Yep. 12.82, you got her. So now how do we find R?
Gonna be, go back to the original one, the inverse tangent.
Okay. Of? You got one of them right. Yeah, the 6.01. Number 6.01 would be here and here. 5.32 is here. And of course back here, but that don't help us any. So yeah, 6.01 is the opposite, 5.32 is adjacent. So what's that give us? 48.45. So 48.45 is angle of rotation. How about angle of tilt? Going to be an inverse what? Cosine of 10 over 12.82. 38 point what? 0.72 degrees. What do y'all think? Wonderful? Fabulous? They're confused, Cody. Sure? Okay. Okay, so here we're machining the corner off of a block. We're looking at it from the front view. We've got an angle here of 18 degrees. Looking at it from the end view, we've got an angle here of 28 degrees. Find, remember the angle of rotation would be the angle like right here that we'd have to rotate it. Also ends up being the same angle that we'd get up here. Then the angle of tilt, remember that angle is found in there, angle T. So find R and T from that information. Tell me where to start.
Anyone?
Give you a little hint.
Step to 10.
Okay, use a depth of 10, okay. Then what?
You take tangent of 18.
Okay, tangent of 18 degrees is,
Over 1.
well, it'll be 10 over A this time, so we're backwards, right?
You want to do tangent of 18 divided by 10.
Actually, the other way around. 10 divided by tangent of 18, right? We'll give you 30.77, okay? Over here, similar thing. Tangent of 28 degrees equals, if I call that B, it'll be 10 over B. So 1 times 10 is 10 divided by tangent of 28 is 18.81. There we go. Now what? R is found by perfect. Inverse tangent of 18.81 divided by 30.77, which gives us R is 31.43 degrees. Find T. What do we need to do? To find T, we need to first find this distance across here, don't we? How do we find that? We've got a triangle. This is 18.81. This is 30.77. This angle, 31.43. The dimension we need to find T, though, is this one across here. How do we find it? That'd be the opposite side compared to our hypotenuse. So we're going to be dealing with a sine. And we'll call that C there is going to equal C over opposite over hypotenuse. So C over 30.77. Then what? Okay, so sine of 31.43 times 30.77 gives us 1605, okay. And now we're going to use that in a triangle to find T. This is our T. This is 16.05. This was our 10 that we guessed for a depth. So T is found by inverse tangent of, okay, which gives us
31.93.
31.93 degrees. How you doing? Do you guys need to review the stuff from yesterday, or are you good with it? You want to review it from yesterday? So this is what we're looking at here. What we're trying to find is on this surface here, the angle of rotation here, and the angle of tilt here, which is going to be from the bottom instead of from the top now. We're going to do this one this way. I'm going to have this as being 18 millimeters. 28 millimeters, 38 millimeters, and 60 millimeters. And this as being 16 millimeters.
What's this?
That would be the height.
Okay.
Remember, the box that you're drawing here is basically right here. So it's from here to here, basically. Tell me where to start. Okay, very good. So I'm actually going to sketch this out here. This, of course, is the 16, the height. This over here is going to be 60 minus, or sorry, this would be 60 minus 28, which would be 32. And this would be 38 minus 18, which is 20. Now what? Angle of rotation is right here. R will be you got it, 20 over 32, which will be 32 degrees. Works for me. And our tilt, how do we find our tilt? Got to find a length. Very good. What do we get for that length of that edge? That'll be the square root of 16 squared plus 20 squared plus 32 squared. 40.99 millimeters works for me. So T will be not inverse cosine this time, but inverse sine of 16 divided by 40.99. Giving us 22.98 degrees for our tilt. How's everybody feeling? Ready for a unit test?
No, but you're gonna.
I've got a question. Can you roll that back a little bit? The 20, where did the 20 come from?
38 minus 18.
All right, I got it.
Okay.